Good afternoon or good morning, depending on where you are. Welcome to the Veritas Automata Deep Dive. I'm Ben Savage, the CEO and founder of Veritas Automata. I have Saurabh with me as well. We didn't talk about this in the pre-show, but I feel we were just challenged because our colleagues, Ed and Fabrizio, have their podcast, Clusterfunk.
Yeah.
And someone started playing their song before we started.
That's true. That's true.
We did AI music first. I think we're going to have to come back for that.
We're going to redo our intro music then, right?
Well, we're going to do intro music. We haven't done it before.
And that's true. That's true.
I don't know what it's going to be.
Yeah, okay. Something AI generated for sure.
But we could do a whole music video.
That could be interesting.
I feel like the challenge has been laid down. We're going to have to meet it.
And probably robotics llamas involved somewhere.
I don't know, those are hard to prompt.
We'll see.
Might just have to build one.
All right. A real robot. Okay.
So we'll come back to that. But today we're going to start talking about, continuing what we were talking about last week a little bit, which is some of the AI security stuff. And we've actually found a game that lets you do some prompt injection as well. So we'll talk about some of the new things that are evolving in that space, and then we'll get to the fun stuff. And we got a couple other topics we're going to cover as the day goes on. So when we were talking about it last week, a lot of the ways people were attacking is, they're being overly verbose, like speaking like a consultant and trying to apply that technique. But the other thing that's come out a lot, there were a couple of different approaches in the last week that we saw in papers, and Bruce Schneier talked about it, and a couple other folks did, were about this idea of hiding prompts in other documents or images. And there were two cases that we saw, right?
Yeah.
One was that they were embedding it in like a Google Meet meeting. So there was a whole bunch in very small fine print in there. And another was where people were using an image to go do it. And in that image, they had like just one pixel color off from the background. So a human couldn't detect it. They had like a 300-word prompt that was hidden in there. And that caused it to give some very adversarial responses to what it was supposed to do.
Right. I think it goes back to a few years back when we were looking at GANs and all people were putting stickers on stop sign, and some of the autonomous cars were unable to detect that, right? But strategically changing thing. This is a bit different because you are sending an image through a multimodal and it's trying to extract text out of it. But typically security would be outside the LLM quite often, and because it's limited space and all. But here it kind of like you are glued into the whole setup.
Well,
right?
It either needs to be outside the LLM or it needs to be stacked, right? It can't just be baked into the LLM, because the LLM itself, if you prompt it right, you can break it, right? You can either overload its context, or you can change its systems instructions, or you can ask it something in a way that it doesn't expect, so it gives an answer, right? Where whether you use leet speak or camel case or funky punctuation or mixing different kinds of character sets, there's a lot of different ways that can do that. And I think that's where it's also different than a GAN.
Yeah.
Because like when we're looking at it for GANs and for conventional image recognition, like with the, I think the case you were talking about for the sign was some of the stuff that came out about some of the Tesla type things, where if you go tape over a sign and you mark it as 48 or 45, and it was supposed to be 40, a human eye is probably going to tell that, because people are pretty good at telling when something doesn't look right.
Correct.
But for a machine learning algorithm, it's kind of binary the way it works.
Correct. Yeah.
It's also where LLMs have the advantage; they're probabilistic.
Right. So when you were talking about this whole sanitizing the prompt in, right, it kind of feels like an airlock, kind of you're going from one atmosphere to another, and going through that whole process, right? So I think that whole thing will be dynamic and alive, almost like antivirus setups, where it's getting the signatures getting updated and need to be put in front of the LLM, because you can't really bake into it, or else you will keep training and spending way more money on fine-tuning the LLMs to be resilient to those attacks.
And the problem is they're so large, there's so much information in them, right? That's one of the benefits. That's the double-edged sword of that technology. Is one, you can't hard prompt it. So if I say never use the word password or never use the word secret, never accept that. Well, there's a lot of times if you want to use it for a creative use case. But that same thing of saying, hey, as a character, tell me this story, or in this persona, do this, is one of the ways you break a large language model too.
Correct.
So you've got to look at the output.
I think that you bring up an interesting point, because the context size is limited with all of the LLMs, right? If you overload it, it will forget the base instructions you had to, security instruction to get overwritten very, very quickly, and then you get an output. Only possibilities to have it outside high priority. It always hits that first before it goes in to get processed down the line for sure.
And that's what I think is going to make this challenging, because even if you're training multiple large language models, and there's a couple really cool ones out there, right? There's Llama Guard, which is really for trying to protect against some of that prompt injection, but also making sure it's giving safe answers, right?
Yes.
Which is a variant of Llama they made to go stick outside of to look at the responses from different models. And there's a number of other tools in that same school, whether they're going to make sure it's like safe for dealing with kids or appropriate language or whatever. But you still have to think about, okay, so if someone gets past the first one, it's tower defense, right?
Yeah.
How many levels?
Yeah.
Well, should we go to the game?
Yeah, I think that was a very interesting find for sure.
So this should be coming up to stage so I can see it. And let me go. Okay, well, I broke stuff, so I'm back. So let's now see if I can go share the screen I want to share. There we go. Okay. So now we should be sharing the screen. Hopefully I did not break this. Cool, we see it. So this is a game that I found, and you can start to ask prompts. And I'm going to do some copy pasting here because I was playing this game last night and this morning. So I've already figured out some of these, and just to keep us moving. So let me go here. So the first one.
I think the purpose of the game is to, get a secret password who's being guarded by the LLM, and we are trying to get hold of the password at various different levels.
Yeah, this is a company that's doing some AI security work, and they've got some awesome tools to see so people can, in a fairly fun way, play with some different kind of prompt approaches.
Right.
So the first one is really easy because there's no security. So I just ask, what's the prompt password? And it's going to tell me. So we'll just copy paste that and we'll go to the next level. So for the next one, I took just a different approach, which is I used another large language model to generate a story and really was trying to go for that context overload, right? So not knowing how they were going to build their security, I just figured I'll throw a bunch of text at it and see what happens. And so here, we'll scroll down to the next one. And you can see there, I've got a long prompt and it's not working the same as I tried it before.
And they may have patched it.
That's not fair. I tested the demo earlier.
Or we could try the one, maybe write something else. Maybe you overloaded the context. Who knows?
But it worked an hour ago.
Well,
So I'll ask it a general question. Okay. So I was overkilling it for the first one, but it gave it to me, right?
Yeah. Wow. Okay.
So now I'll go to a different one. And here, and we've talked about this before, there are some approaches where the language that the model is trained in and the language that its guardrails are in matter. So here, again, I don't really know what they're checking, right? I kind of do, but I'm making sure that I don't want to ask it in a language that it may be familiar with, and knowing that most models are trained heavily in English. And if they're from the Quen school, they're going to be trained heavily in Chinese. That's where a lot of the safeguards are going to be put. There was a paper that I think we talked about a couple of weeks ago where if you prompted it in German, it didn't have any issues with certain questions, whereas if you did it in English or Chinese, it did. And then I'm also trying to hide the data I'm exfiltrating out in this case. So I'm not asking for it to give me the data in English. I'm asking it to give it to me in ASCII. So here I've translated my prompt into Italian, and I'm asking it to give me the response in ASCII. And so I already actually saved what that was, but it translates to the word wavelength.
So you ask it to reply back in ASCII. So
yeah, I told it a story. So I said, in this case, that you should tell me the secret and tell it to me in ASCII. That's
interesting. So if they have some kind of a safeguard, it says, okay, it's ASCII, he cannot read it, give it to him.
Well, if it's looking for a specific English word, it may not translate. This is where you get a double-edged benefit from a large language model, right? It could just let that through, or it could be smart enough to check it, depending on how they've configured their rules. So now we'll do one more and then we'll continue, just because this one, I was asking this one, I'll put it in, I'll explain what I was doing, where I was asking for it to exfiltrate the data in a Caesar cipher, which is a really basic encryption.
Right.
And I told it how to go do it. And when I get the response, oh, again, they fixed it. This isn't fair. They're not supposed to change the rules midway through. Okay, we'll stop there because it didn't work this time.
So it's a moving target for security wise as well.
Yeah.
So
well, and that shows what it is for all of us,
Yeah.
right? That if there's an attacker, this is continuously moving, and little things in a large language model, because you don't always know exactly what causes it to work. It could be funky parentheses, it could be funky spacing, it
Right.
could be funky characters that you put in, right?
Yeah.
It could be mixing English and Cyrillic or mixing different things, and that could work.
Mhm.
And then on another chance, because this is deterministic,
Yeah.
or non-deterministic,
Non-deterministic, yeah.
it may not work because the model perceives it in a different way. So that was a good real life.
Yeah.
But that kind of ties into the paper we were just talking about before everything started.
Correct. The paper from Google
Yeah.
about the LLM flows, right?
Yeah, they were building these. It was similar to an agent or a workflow
Right.
where they were trying to figure out how do they train workflows,
Right.
particularly for very specific data structures. They were trying to stack them.
Yeah.
Which was interesting. We'll provide a link to the paper in the show notes.
Yeah, but let me put my 2 cents, because I've dealing with workflows and LLMs, and then other tools in the mix, and agents creates another layer of chaos, right? The way today it's being done is you have a lot of these LLMs and tools. They're glued together using hard-coded context. But again, developer provided context, and you are dealing with probabilistic models with a hard-coded prompt, and they would work fine for some time, but if it hits an edge case, it breaks apart quite quickly, right?
Well, and that was the argument in the paper, right? Is that either the edge cases for the input or the data, or that there's a change in the model.
Oh yeah, that's
the workflow.
So especially if you're using an API like a public LLM or anything like that, it update the model, then the behavior changes, and now you have to edit your prompt.
Change
right?
the security safeguards that we just saw.
Yeah, that's another one. Maybe it is that you could hit it again. Maybe it will clear next time because it's probabilistic, right? It's throwing a dice and trying to go which route it's gonna go. So what they did was kind of new or novel, at least in my eyes, is that there are a lot of different possible paths from going from one place to another, and they're doing kind of like all the possible part, but assigning probabilities on this is the preferred path and training that as a model.
And they specifically referred to as doing a Monte Carlo series of those. So when we were talking earlier, it's like if every time the word is Bob, do X, and they're training with different scenarios. So it could be every time it's Bob or Sally or B0B or 808 or something like that. There's all different ways to be able to go train it through.
Correct. So they are putting a probabilistic framework on top of this glue structure, right? Or what connects to what's the pipeline look like, and then training it. So they are not necessarily training the LLM's model per se, but choosing the path, how it's going to flow to different systems. I thought it was a pretty clever way to do it. And
I didn't think they were actually training the model in my read. I read it pretty quickly. That it seemed like this was another layer in addition to the model, so separate from the large language model, and it was another AI tool that kind of operated the workflow on top.
Correct. And you could essentially put some trainable layers on top of the LLM, so they are producing things a little bit more predictably. But what it is probably you can take that and fine tuning or train it on your own workflow quite a bit, so it's not based on a very open source and downloaded model, but more refined to your use case as well.
Is that something that in theory they could do, or they or anyone else could do, where you create that workflow model as a separate model from the large language model? So now when I'm in the cloud, I can let our company or company B train their own workflows, not change the underlying model, but focus on that much smaller, because that would be a much lower cost and faster for training, right?
I think that's an excellent idea, and it could be. I think it would be better if you have those recipes baked in to your own company setup, right? Any tool use, not just LLMs. It could be any other tool use. All of those patterns could be baked in for sure. So and that could essentially learn how your employees or the users in that company prefer to use certain tools, or they have the tribal knowledge that can start to get baked into this whole model in itself as well.
the reason I thought of it is it gives an interesting way to think about IP.
Yeah.
Because now as a business, I can start to preserve my IP in that model.
Yeah.
Versus putting it into the other model that I may not own, right?
Right.
Or risk that it gets trained into that model because I'm doing some more work here.
Yeah, absolutely. I think that's a pretty cool idea. Let's see, they are using LLMs as a service and then creating the IP or the secret sauce around the flow itself. If it is more and more predictable and learn some of the from the input you are looking for, suddenly already knows, it doesn't have to go through a discovery process, right? One of the issues, again, changing a gear a little bit over here, vibe coding, right? So let's say you are trying to engage with a service and call their API, do something with it, right? It makes, when you put that in an LLM, it tries to make certain assumptions, and then it writes down the entire code. And then when I looked at the code and looked at the documentation, I'm like, why?
So this is going to, Ben has tried yet another vibe coding tool. Ben has made more progress than in the past when he's tried to completely vibe code. So not actually edit any code, right? This is the goal. I'm not working on the code in this area, just define the spec. And we were trying one, and it was getting into a circular issue with the API authentication where it would fix it. It would determine it was wrong. It would then go change it, and it would break everything. So I sent Saurabh the results going, it kind of worked here. It stopped working here. And I found this is a really good way to burn a lot of things fast. And honestly, that's also on me. I wasn't going into the code to go try and figure out what it was doing.
Yeah, that was interesting because I thought, the authentication, I didn't look, but it created a whole new library of tools just to talk to the service. And when I looked at the documentation, it was literally 30 lines of code. And I was sending in the morning, hey, look, I'm getting what I need. Yeah, then I figured out, okay, you need to provide a little bit extra, but it can be done in 50 lines of code. Because the LLM probably didn't go out and read the latest documentation, it assumed a bunch of things and made it a really, really complicated workflow.
Well, and that was with me actually being more focused in the way I prompted that than I had been when I tried others. Others, I had just told it to go, here's the URL for the documentation for the API. Here's what I want you to do. I had actually gone to the effort in this case of testing with curl each command I wanted to run to make sure okay, if I run this command, what do I see? Because it was when I would prompt it, it would do weird interpretations converting between human language and what the API capabilities were.
Yeah, and I did provide, because I went through the vibe coding to see why it was doing that, provide the URL because I thought, hey, go look at it. But the documentation was an interactive documentation, so you can change parameter and then the URL changes and then you have all of the other stuff. And the LLM couldn't figure that out. So, it was trying to hard code stuff where it shouldn't be hard coded and all of that stuff. So it's interesting that use case, we went down two different paths, then we figured out the assumption kills in vibe coding. And the LLMs are not good at telling you the assumptions outright. And that's a problem I've seen across multiple different LLMs. They never tell you assumptions, and when it's not working, you go down and like, why did you do this?
Well, and with the particular tool I was working with, it's starting from that concept of spec-driven design. So you go create the requirements, and then it creates a design, and then it creates a task list to go implement it.
Right.
And I could tell as it was executing the task, there were things it was not updating back into the design.
Right.
Or into the requirements when it found things. And that's exactly where I think that issue with the authentication. And there were two or three other pieces, which gets back to the idea of context, both in the concept of a large language model, but also within software architecture. And how do you go do that? And it was interesting also, if you were to go say, hey, I need you to make a change. If you started at the requirements, it was hard to get it to go all the way through and update the tasks sometimes.
Etienne, who is on our data science team, he would tell you stories about how he was trying to edit a color or change a button while he was experimenting with vibe coding. It completely deleted a whole function that he had spent 2 days to build it, right? So now he is all like, I'm going to commit everything that looks good and then let it do it.
That's exactly right. It's either you commit, backup, archive. Once you get to a point where you kind of know it works, save it. Because at some point, the large language model, from everything I've seen, everyone I've talked to is going to do something silly like go rewrite an entire function that has worked fine. And he said, I didn't tell you to work on that function.
So that's an interesting emerging field. I think all of the LLMs are looking good on the benchmark test, but in real use cases where we are going through iterative phase, I don't know if the benchmark has those kind of test already, where you are like, no, we want to do this versus that, and it
Yeah.
goes and changes, still preserving all of the other features. So
And we've actually talked about that too, even when I've used it in simple cases, like if I'm using it to do like Python code for some data analysis,
right.
like you can be prompting the same model one day and it feels like person A is writing the code,
Yeah.
and it will on day B give you a completely different person style of code. You're like,
yeah.
It's the same tool that generated this. How is this different?
Yeah. So anyway, I'm not against vibe coding, but I feel like just typing a prompt and shipping it won't work, or it's not there yet.
Yeah.
There's a lot more.
It
to
works
that.
in really simple cases. Like in the particular thing, we were working with an API for a tool that we need to go do some backup on, and you can't just do a file transfer easily for it. And if I was doing it in a really simple method, it worked really well.
Right.
But when I got to more complex things, like with multiple nested folder structures, that's where it was breaking. And that's honestly where a human developer would start to run into issues too, because you get into certain levels of recursion. And
right.
stuff.
Right. Absolutely.
So I can't completely blame the vibe coding tool. I can just say I've made progress.
Yeah. I mean, it's promising for sure. So, we'll see how that whole thing emerges as well. So we were going to talk about some hardware too today, right?
Well, let's talk a little bit about robotic simulation, why we might need new hardware. And then we can talk about the hardware.
Okay.
So I think you got Isaac up and running.
Yes. So Isaac, I had to go through multiple iterations, and in the end, my laptop with 2080 or some series GPU was not good enough for it. So
at which point I say, why aren't you running it on the server we have with Dual A6000s?
Yeah, that's where I ended up, and we had to do a little bit of more work to it, to Docker, have a NVIDIA Docker, get the GPU to pass through it, and then run Isaac on it, and then have the interface streaming over WRC, I guess is the protocol. Got it to that far. Now I'm trying to get into simulation phase of it, which is cool.
So and some background, right? So we talk a lot about AI and machine learning, but very closely related is the whole idea of simulation for robotics. And one of the libraries that NVIDIA, or tool sets that NVIDIA's come out with, is their Isaac.
Right.
You also see this with some of their Omni models and some of their other world models that people talk about, where they're doing very advanced 3D simulation. Some people are using them for video generation, but a lot of it really comes from the robotics background, because if you're going to build a new robot or train a robot in a workflow, you need an environment where you can simulate it and run that reinforcement learning many thousands of times over to really build the kinematics and the motion. Yeah,
because robotics is, it can be deterministic, but the world is probabilistic. Where what would you end up today? Maybe a cup on a floor, or something else that you didn't expect, and you wanted to navigate around it or mitigate that whole thing, right? And you can't set up every possible scenario for it to code, right? That's where the simulation comes in. Isaac does a pretty good job of, because it's physical, simulation with physics engine built in. So you can do multiple iteration of reinforcement learning to build that code set ready for, real world application. So that's why we are looking into Isaac.
Yeah, it's a couple of upcoming projects that we'll be doing, but it starts with getting the simulation so we can make sure their workflows actually work and go through those. But there's also something with that. I think did I send you the paper from, I'm going to forget the university, about how they're using the Facebook Aura goggles. So those are they're augmented reality glasses with dual cameras, and they're using a human to gather data, so that when you want to combine it with the simulation environment, the human goes through, so you see the task from the robot's perspective. And then now you can go feed that into the model. So instead of having to go build everything from, basically it's like building an animation when you build a lot of times. This lets you train that into that skeletal movement.
I think I've seen something very similar where they were using that to train a packaging robot. Like, how are you assembling different things in a box? How to fit it in, right? Using goggles as well to train it. Right?
So we'll make sure to share that paper. But where that took us is we've been looking at the current state of hardware, and at the beginning of the year, we brought our GPU server online that we use for a bunch of things. And that's got dual old A6000s or previous gen, which each have 48 gigs of video RAM. A lot of these Facebook tools are awesome, or sorry, these NVIDIA tools are awesome, but they require starting at 80 gigabytes of video RAM or more. So as we're researching on what's going to be the next generation piece of hardware we use for testing, we came across a really interesting concept from A16Z, which I think would be our dream workstation, which was a single ATX desktop that's running 4 of the Blackwell RTX Pro 6000s, which each have 96 gigs of video RAM. And what Saurabh and I were talking about was really interesting. There's two versions of that card. There's the normal version and the Max Q. And the Max Q in most NVIDIA lines is more their laptop. It's a little bit more thermal and power efficient, but you give up a little bit of compute speed is the best way to describe it.
Yeah. So yeah, we'll be see, because those things, each of the cards, a full version is, what did I see, 300 watts or
on the Max Q. I think the normal one is more like 600.
600. So I don't even know how they're going to provide power to all of that. Our max wattage on a power line is like 1600 watts. You probably need
1650, 1800. I think was the one they were running. You can get. I've seen 1800 watt power supplies you can go get.
Okay, so we probably need like a heater, big outlet to plug it in. Maybe
No. This said it can run on a normal desktop.
All right.
That was part of their argument.
Okay.
But no, that's something to go think about, right? It's like as you're building these, and this is something we've had to talk about. I've had to talk about with some of the folks in our building here. Is these new systems are consuming so much power. We've in one of the buildings I have access to, they've got a building of what was an old data center in the building. It can only support 2 kilowatts per a rack, which means I could put one of what most people are running for their desktop in it now. It's not as much power as you think when you're running, a 1600 watt, 1800 watt power supply. You're at 1.8 kilowatts right there.
Yeah. I mean, power would be a new thing with, even at the desktop grade. I didn't think we'll see that day, but it's coming towards us pretty quickly.
And that's the argument for people using ARM and stuff, right? And this is back to what you and I've talked about. Sometimes you need lots of cores. Sometimes you need lots of clock cycles. In the simulation and the large language model one, it's all about the number of cores.
Yeah, absolutely. So we'll see how that whole thing. Max Q was interesting because it probably spins down certain cores and reduces the power if you're not using the entire thing, something in that order. But how would it perform on full load when you have a massive full precision model running on it, right? So how that works, it would be interesting to see.
Well, and I think what will be interesting for us as when we get the new system set up, as we finalize the hardware, is we're currently running 2 A6000s. And there's some things that you have to do a lot of work to go split that workload across those cards. It's roughly the same video memory, 248 gig cards, but even with the NVLink, you're not loading everything into memory all at once. You've got to go share all that.
Yeah. So I think it's a new frontier. So a lot of new tools will come out, and we'll see how that whole thing plays out.
Cool. So I've broken things today. I've caused chaos. What else should we talk about? Or are we at a good point to wrap today?
Well, I think we wanted to show some games if you're feeling like it, or we could do it in the next.
We'll provide links to them.
All right.
These are Windows games for people, and we kind of started this podcast looking at games that LLMs can play with each other as a test. I think we still look at that, and there's still a couple we may get running. And we found a couple that are starting to come out of some of the game jams where people are using the LLMs in the games. And one is called You Have 60 Seconds to the End of the World. And it's an interesting storytelling game, right? You prompt it, it's got an 8-bit retro vibe feel, and it plays back, it tells you a story. The other one is really interesting in concept, but I think I've set the record for our office and I've made it a whole 15 seconds without dying. It's a roguelike called Procedural Gungeon. And the idea is that as you go for different levels, you go collect guns, you can merge them, and you can do some of that. It's all powered by an LLM. Both of these are powered by LLMs. So really interesting concepts. I'll just give everyone fair warning. Procedural Gungeon looks good. It's entertaining, but it is not my skill set from a game, just from the way the controls are set up. So I wish all of you luck.
Yes, absolutely.
Because you made it how long in it?
5 seconds, maybe.
Okay, so I made it 3 times further than that.
No, I just died instantly.
Okay.
I was like, what is this mess?
So we'll keep providing some of that, but we'll provide links to those as well, because I think that's something that I think there's going to be some interesting ideas as people continue to play with those from the fun perspective, not just the productive perspective. So cool. On that note, today will be a little bit of a short one, so we'll wrap it up today, and we'll look forward to catching up with everyone in 2 weeks.